So, good morning to everyone. I once again welcome you all for the fifth day, second session of ATAL FDP program. It is my honor and privilege of welcoming our resource person, Dr. P. Ramesh sir. He received his UG degree in electrical engineering from Institution of Engineers, India in the year 2006 and received a M.Tech degree from Dr. M.G.R. University, Chennai with specialization in applied electronics in the year 2008 and PhD degree in electrical engineering from Anna University, Chennai in the year 2018. Dr. P. Ramesh is presently working as an associate professor in the Department of Electrical and Electronics Engineering at CMR Institute of Technology, Bangalore. Dr. Ramesh's research interests include power electronics applications to renewable energy sources and electric vehicles. He has published more than 23 research articles in various international journals and conferences, and 6 patents were filed and published. Also, he received Best Teacher, Best HOD, Best IEEE Paper Awards. It is my honor to welcome him for this session. I welcome you, sir.
Yes, madam. Thank you.
I hand over the session to Dr. Ramesh, sir.
Hello, Dr. Ramesh sir.
Yes, sir. Professor.
Mittal sir speaking.
Yes, Professor, sir. How are you?
Fine sir. How are you?
Yeah, fine, sir.
Okay. Oh,
How is going on there, sir?
yes, everything is okay here.
Yeah.
Yes.
Thank you very much, sir. You are the senior professor. You are also joined, means I am very happy.
Yeah. Uh,
Okay, sir. Let me start, sir. We will start.
okay, sir.
Thank you.
Okay.
Thank you. Yeah, ma'am, screen is visible, ma'am.
Yes, sir. Is it
Sir, yes,
visible,
sir.
sir?
Your slide is visible, sir.
Yeah, okay. Thank you very
Okay,
much.
sir. Thank you, sir.
So, very good morning to one and all. First of all, I would like to thanks for the management, principal, HOD ma'am, uh, and coordinator Shyamala Gauri madam for giving an opportunity to speak in front of all of you. ATAL FDP, uh, ATAL, they are taken so many initiatives. One of the initiatives FDP uh, for faculty training. This will gives more opportunity to learn everyone. So we thank for government and organizing and Erode Secondary Engineering College, all team members, coordinators, everyone to give an opportunity to speak in front of us. Okay, let me go for our today's session. Electric vehicle challenges and opportunities. So So this is my outline of the presentation. Overview of electric vehicle. Just I will complete briefly. Challenges, because last few days we are discussing so many things about the electric vehicle. Just I will give overviews and then enter into the challenges and then opportunities of electric vehicle. And storage for EVs, why lithium ion batteries for EVs, and fundamentals of battery pack design, electric vehicle cost, charging station, finance and ownership. First, let us go to why so much interest in EVs. Nowadays, not only government, the peoples are also started to show interest, because we aware of that the petrol and diesel price, how much now, as of now, uh, we have to spend huge money for fuel itself if you are having the vehicle. So that is the major issue we are facing. And also, if you go with the electric vehicle, if you see the energy efficiency is 4 times greater than the IC engine. So that is one of the most advantages why we are going for preference with EVs. If you take internal combustion engine, around 22 to 23% of efficiency only we can get. But in case of motor energy efficiency is around 90%. So this will be the biggest advantages for us. And also the day by day, the number of vehicle increases, demand increases, then availability of petrol and fuel is also decreases because uh, how far you will get the source, that will be important, one of the important question mark. So demand is increases, and cost of the product, cost of the fuel is also increases, then the efficiency will be very less when compared to electric vehicle. And also if you see the moving parts is 50 times less moving parts if you go with the electric vehicle. So just I given one data from the 1981 to 2015, how much petroleum consumption is there. So in the year of 1981, around 32.5 millitons petrol consumption we made. Now it will be increases to in the 2015 184. Now 2021. Now the demand and requirement of petroleum is very more. So the cost is also nowadays increases. So these are the reasons mainly we go for electric vehicle. Then why still we are speaking more than 10 years we are speaking about the electric vehicle eagerly. So everyone will know that about this. But still we are facing problem to switch to EVs. What is the reason? What is the problem? What is the reason? Uh, why we are not ready to switch to EVs? Even for example, many people they are attended the FDP program. So suppose if they have planned to, so many electrical engineers are there. So if they have planned to buy one car means, so maximum 90% of people will go with the IC engine only. Still today onward, today also, tomorrow if you are going to buy the car means, we can think of to buy only the internal combustion engines. Still we are not ready to go for EVs. So what is the main reason means? Mainly the battery. In electric vehicle, mainly we are seeing the battery. So battery actually we are using for energy storage. In the battery, the weight of the battery, volume of the battery, and cost of the battery all are related to each other. As per concern of the electric vehicle, the battery cost is the dominating cost. The other costs are very, very less when compared to IC engines. Only the battery cost. Battery cost is the dominant cost in the electric vehicle. So the cost, weight, and volume are related to each other. So this is the main reason we are not ready to move for electric vehicle. So when you go for electric vehicle, that is the density. Energy density is very important. So normally we are using lithium ion battery. Nowadays we are used to use of lithium phosphate battery also we have started to use. So when you go with the lithium ion battery, the energy density is continuously increasing. So the higher energy density will give higher safety concerns. If you see the cost of the battery and energy density, both are inversely related. So, but we have to reduce the cost, but we require higher energy density. Okay, so we have to reduce the cost and also we require higher energy density. So our main motto is to reduce the cost. So what we can do means to increase the higher energy density with the lower cost, we can go for using lower use of materials like lithium, cobalt, nickel, manganese, graphite, etc. If you compare the lithium ion versus petrol energy density, the petrol energy density is about 12,500 watt hour per kilogram. Even if you're taking into account 4 times higher drive efficiency, the battery weight per kilometer is 10 to 12 times higher than that of petrol per kilometer. So that is the issue. So weight, cost, and density. So the size per kilometer is 5 to 6 times higher. Size per kilometer is 5 to 6 times is higher. Just I am comparing the lithium ion battery versus petrol energy density. So why we are lagging to go with EVs means mainly battery, I told you already. So this battery energy density cost are relate one among to relate each other, and then weight, cost, energy density, weight. So many of the research going on these to reduce the size of the battery, weight of the battery, and cost of the battery, and the same way to get higher energy density. So many types of batteries, so many different types of cells we are learned, we are studied, we know about that. But especially we are using a lithium based batteries because the life cycle is more. Okay, life cycle is more compared to all other batteries. And we are facing some challenges. When you come to challenges for electric vehicle, limited range. So limited range means, for example, Tesla car now it's available around 540 kilometer. Uh, Once if it charged means around 540 kilometer it can able to run. So maximum run. So limited range for long run, long travel, it is not suitable. That is the limited range. We are facing biggest challenge in the electric vehicle. For daily running, for daily office work, within few kilometers daily we are running means the electric vehicle is very good choice. And long charge times. So charging time is required long and high initial cost. I told you already, when compared to IC engine, the cost of the electric vehicle cost is very high. Mainly the battery cost is battery, and then motor driven cost will be mainly higher. Even the motor and controller cost is less, but the battery cost is the majority cost of the electric vehicle. That is the dominant cost in the electric vehicle. And then battery life. Next important is battery life. So battery life, within a few years we have to replace the battery. So already I told you that the cost of the electric vehicle is battery cost the dominant cost. So if you want to replace the battery means we have to spend more money for the battery. Then consumer acceptance. Consumer acceptance is based upon these challenges only. Still, it is we are getting less from the consumer side. And grid integration. When you grid integration means our government, the world level, each and every government having certain policies. In the year of 2030, they are maximum planning for electric vehicles. At the time, the demand of electricity also increases. So already they are planned based upon the requirement and demand. Go with supply of grid system, integration of variable renewable energy sources with grid, and supplying the and meet the demands. So these are the main challenges we are facing in the electric vehicle. And if you see the India's vehicle dominated by two wheelers. So here some data I given. So from the survey 2013 to 14, 14 to 15, and 15 to 16, similarly up to 18 to 19, uh, the increase of vehicles, electric vehicles, you can able to see here mainly the two wheelers. If you take two wheelers, see there in the 2013 to 14, 14.81 will be there. Now it will be increases to 21.18 in the year of 1890. Now 2021 it may be increased more than this. Okay, so here in India, the electric vehicle is dominated by the two wheelers. And similarly, e-rickshaws also, three wheelers also increases. When most of the peoples for public transport, they are using started the use of three wheelers, around 75% of Indians. So the cars, 14% of total vehicles, it may be increases. And premium cars with the cost more than 1 million is about 15%. So here also one tabulation will be there in the year of 15 to 16, 16 to 17, and 17 to 18. So you can able to see the range of variations from last 3 years. The next, how will the EV sales grow under the different scenarios? Different scenario means, for example, if you are considering a 10% scenario or a 20% scenario or 40% of scenario, how the sale of electric vehicles forecast in the forthcoming years for various financial year 21, 22 up to financial year 30. We are forecasted based upon the scenario. Scenario means if it is increases 10% scenario means how it will be there. 20% scenario means how it will be there, and 40% scenario means how it will be there. That will be shown in this graph. So in EV cost in India and energy per kilometer, this is very important because the EVs without battery cost less than that equivalent IC vehicle. So the battery cost is more. That's why the EV cost will be very high. So actually, when compared with the IC drivetrain, EV drivetrain is more costly. So what we are means now, while go with the electric vehicle, we are replacing the IC drivetrain instead of we are replacing the EV drivetrain instead of IC drivetrain. So for IC engine requires low cost petrol tank to store the fuel, but EV requires expensive batteries to store the energy. So battery is the extra cost in the EV and is a dominant cost. So focus on higher energy efficiency. Lower the energy used per kilometer. That is very important. So we have to per kilometer the energy required should be lower means then we will get higher energy efficiency. That is the concept we are using. The another thing is we have to lower the battery size, and its cost. So energy density requirement, if you are reduced per kilometer, if you are reducing, and then similarly battery size we are reducing, cost we are reducing means then the electric vehicle adoption will be increases day by day. So this is the major issues, challenges we are facing. Okay. So we have to improve the efficiency. How we can improve the efficiency? Once if the efficiency improved means what is the meaning? The low energy required per kilometer is lower. Once if the energy is improved, how the efficiency will be improved means by using a suitable motor or controller efficiency, and then better tires. Better tires means the tires should have low rolling resistance and better vehicle aerodynamics, and then lower weight. So these are all the causes to improve the efficiency. If you concentrate all those things means the efficiency will be improved, then lower the energy used per kilometer, then battery size also reduces, cost is also reduces, then people will try to move towards the electric vehicle. Here just I compare the capital and operational cost of EV battery. So here you can able to see in the tabular column in the battery size is 1 kilowatt hour, 2 kilowatt hour, 3 kilowatt hour, 4 kilowatt hour. So if you are going for increasing the size of the battery, what happened? The battery capital cost will be decreases. Okay, the range of increasing battery cost will be decreases. For example, for one kilowatt battery, 1 kilowatt hour battery, the battery capital cost around 18,000 it will come. But if you go with 2 kilowatt hour, instead of 36, it will be reduced to 33. So likewise, I am saying if you go with higher kilowatt hour, that is increasing of battery size, there may be chance to reduce the overall cost of battery capital cost. At the same way, the energy efficiency also increases with the increase of battery size. So based upon the two-wheeler and three-wheeler, here I shown. Here I given one example, just you can see. For a 100-kilometer range, if you are going to compute the size reduction with the efficiency, so if you 25 watt hour kilometer to 15 watt hour kilometer, you are going to reduce the 25 watt hour kilometer to 15 watt hour kilometer means, right? So what is the battery size? Battery size means, for example, first 25 watt hour kilometer, what is the battery size means 100 into 25 watt hour. So 25 divided by 0.85. So 0.85 is the capacity usage, battery usage capacity is 0.85%. Okay, so that's why I'm putting 0.85. which is equal to 2.9 kilowatt hour. So battery size, see the battery size. When you are reducing, suppose if you are reducing the battery size, you have to run a battery. For example, you have to run a one car for 100-kilometer range. So 25 watt hour kilometer to 15 watt hour kilometer, if your size reduction with efficiency, with required efficiency, if size is reduction means, see the battery size, how much it will be reduced. For same example, 25 watt hour kilometer, the required value of battery size is 2.9 kilowatt hour. Here 1.8 kilowatt hour is the required size. Suppose if it is reduced to 15 watt hour per kilometer. So the cost is also reduced. For example, for a 25 watt hour kilometer battery, cost is 43.5K, means now it is reduced to 30K. So without affecting the efficiency, if we go with reducing the size of the battery means, then the cost is also decreases. So the computational cost of the battery will be decreases if you go with reduction of the size of the battery. With the same efficiency we have to operate. So the next is another technology, battery cost reduction strategy. What we are using means, we are increasing the energy efficiency of electric vehicle. We are going to increasing the energy efficiency. Energy efficiency means, for example, battery size is reduced to 35 to 40% over last 3 years in India. So if we take last 3 years back and compare to now, the battery size of the battery, because most of the research work is going on. I told you already, the main issue, main problem is battery. So that challenges, that issues, many researchers are going there. Further development of the battery, what will happen means, now compared to last 3 years back, the size of the battery is reduced to 35 to 40%. So 35 to 40%, the battery size will be reduced. For e-autos, if we take for e-autos, 70 to 80 watt hour per kilometer should be reduced to 45 to 50 watt hour per kilometer. Similarly, for e-buses, 1600 watt hour per kilometer is reduced to 900 watt hour per kilometer. So this much of changes will be happen in the last 3 years. This may be continuous in the next 3 years. In the next 3 years, it may be further reduction, maybe chances will be there. And also reduce the battery size. So we are using a smaller battery will reduce the cost. We are using smaller battery will reduce the cost. Mainly, for example, daily we are going to run 100 kilometer. If you are going to run only 100 kilometer daily means, based upon that you can choose a suitable value of battery. So this is the one of the scenario we can follow to reduce the battery size based upon your requirement. Next one is, we'll go with the business viability for public transport. We are going to split the battery into smaller and swap whenever you require. For example, if you want to design a 90 kilowatt battery, 90 kilowatt hour battery. So 90 watt hour battery, for example, I will take 90 watt hour battery. If you want to require a 90 watt hour battery, instead of keeping one 90 watt hour battery, I am keeping as three different batteries. That is 30, 30 like that. Okay, 30, 30 like that. So what we are doing means, whenever charges will be less means, one battery source will be discharge means, then you can go with swapping the battery. That is the one of the technique we can use. Split the battery into smaller size. See the 1/3. We are making a 1/3 smaller size, and swap whenever required. We can go for swapping also. And main thing, swapping means actually we'll go with charging the battery with short time period, short duration. This will affect the battery life, that we have to take care of that. And also fast charging. We'll go with fast charging at above 45 degrees C, that will affect the battery life. Then when you come to battery swapping advantage, what it will be there means, so for a we can do it as a separate business, because you will get a different business opportunity. In some foreign countries they are using like this, but still it is not implemented in India. But we can go with battery swapping business, that will give a very good business learning opportunities also for people. The public's requirement. So everything it has to be happen means the usage of EVs from the consumer side it has to increase. Then only all those things is possible. Next one is we are approaching approach to is what private vehicles. So we already discussed the batteries dominate the cost of an EV. The larger battery, if we take larger battery, increases its cost. For example, I told you already, the Tesla car they are using the battery for to run around 540 kilometers. Okay, so Tesla car is the largest. It runs largest speed, and they are using larger battery because once if what we can clear how the kilometer 540 kilometer it has to run means definitely the size of the battery is very large. Okay, size of the batteries per day once if it is charged it has run for up to 540 kilometers means definitely the battery size will be more and increase the cost also, larger battery and increased cost. And also vehicle weight. Vehicle weight is also once battery is increases, cost weight is increased means the overall weight will be uh, increases. Once if overall the weight of the vehicle increases means what about the energy efficiency? So the energy efficiency will be start to reduce. So energy efficiency is what start to reduce. So that's why see we can get an idea in the future. In you just compare the car, compare the car material build up quality. Now the build up quality is very less. I'm taking the IC car itself, IC vehicle itself. When compared to olden days, you people while we are in this small age, at the time also vehicle is in our home. At the time, the quality of the product. So the build quality is very less nowadays. Okay, that can easily identified. So why they are going for reducing the build quality means everybody it's a competitive. So everybody trying for increasing the energy efficiency. If you go with the energy efficiency, increase of energy efficiency, they have to reduce the overall vehicle weight. So for reducing the overall weight, if they are reducing the overall vehicle weight, automatically the energy efficiency will be improved. So that only happen in the market, but the quality of the product will be very less. So build quality. So for example, you can take many products in our Indian products. For example, Maruti and all, the build quality is very less. So when compared to Maruti, Tata is somewhat good build quality. So like that I am saying. So they are concentrated on the energy efficiency. They are losing the quality of the product. So build quality is loses there. So in the similar case, what we are doing means in the Tesla car, they are used a larger battery size. The cost is also high, weight is also high, but the energy efficiency, because the weight will be more means automatically the energy efficiency will be decreases. Then another one is smaller battery creates range anxiety. Range anxiety means, for example, daily you are going to run minimum uh, distance. Minimum distance means you are not going for too long. Too long. Daily you are going for office and then coming back to the home means. In that case, we no need to go with higher battery ranges. Higher battery ranges. If you want to extend the kilometer range means we have to go with higher battery ranges. Battery capacity you have to increase based upon your traveling kilometers per day. You can choose the suitable value of battery that will be best for you. And also we can easily go with fast charging in the public place. Suppose during the waiting time or during your parking the car in the office, that time also you can able to go with charging the battery. But always you can go for preparing slow charging, not for fast charging. In case of emergency, we will go with fast charging, but fast charging is not advisable for battery life. And also And the worst case, the temperature should not cross as the 40 degrees centigrade. That is very important. Then extender batteries. We are using electric vehicles with two small battery slots. One with fixed with low cost limited range battery. The another one is high cost battery, high cost larger range battery. So we can make provisions like this. Based upon that, we can go for replacing. For example, if you take limited range battery, example 100-kilometer range for a e-car, enough to drive within the city 90% of the days. So 50 kilometer for e-scooter. You can take our e-car or e-scooter around 50 kilometer per day if you are using means then you can go with fixed low cost limited range battery that is suitable for that. Okay, so use only night time, that is slow charging. So you have to charge the battery during the night time. Once the vehicle is at rest, so we can able to maximize the battery life. We can able to maximize the battery life. And the second would be an empty slot to add range extension battery when you need it. So I told you already, we are making two small battery slots. We are using only one battery, only one battery, and regularly you are using for a short distance travel day wise. Second, we are made one empty slot. Now that time you can add additional battery whenever you required. Suppose your range extension of the battery is required, that time you can able to add the additional battery in that slot. So you can make two slots. One is for regular usage. When you go with a longer distance, that time you can add the additional battery. If slots are available means, then it is very easy to add. So this is the conventional approach. We are choosing the right size battery for the desired range. Right size battery for desired range means we are charging the battery slowly and fast charge when needed. When it is required, at the fast charge when needed, it may affect the battery life. There is no issues in that. The next thing is battery capital cost. So the battery capital cost are very high. So the battery capital costs are very high. We know that already. So why the battery capital cost is very high means we have to see the battery life, because one of the challenges I told you already, battery life in the EV vehicle. So if it is gives a long battery life means then only we will go with preference of electric vehicle. This battery life is depends upon the multiple factors. This battery life is depends upon the multiple factors. So what are the factors one by one we can see? The first factor is what? Number of charge and discharge cycle of the battery. So the number of charge and discharge cycles. So while buying the battery, I told you already, the charging and discharge cycle of the lithium-ion battery is high. That's why we are giving preference for lithium-ion battery. And similarly, the density of the battery is also larger. So the number of charging and discharging cycles for lithium-ion battery is larger when compared to all other batteries. That's why we are going for usage of lithium-based batteries. Then battery chemistry, that will be depends upon the manufacturer. So the rate of charging and discharging, that is very important. So charging the battery and discharging in what rate? Either you are charging the battery with faster or slower charger, fast charging or slow charging technology. Similarly for discharging also. So this will, if you go with higher charging and discharging rate, what happens? Overall, it reduces the life of the battery. And also, if you go with usage of temperature above 25 degrees centigrade, above and below 25 degrees centigrade, it will adds the battery life. But in the worst case, don't go more than 40 degrees centigrade. Then operation region of charge and discharge. There will be a certain limit will be there. That is called the depth of the discharge. For a battery, there will be a certain limit will be there. You don't go below the depth of the discharge. Well, that region you have to maintain charging and discharging based upon your DOD. And also calendar life. Calendar life, once, for example, the life battery is 1 year old means definitely the capacity is 1 to 2% of the overall rating, overall capacity will be decreases. So what happened when the calendar life increases, there will be a chance to, not a chance, there may definitely there will be reduction of capacity of the battery certain percentage. For example, 1 year around 1 to 2% of the capacity will be decreases. The next one is state of health, that is called SOH. In battery, we are using this word DOD, SOH, SOC, EOL, like that. So, state of health is the measure of battery capacity remaining as the battery is used. So, this is very important. A EV battery at the end of the life, when capacity is reduces to 75 or 80% of the initial capacity, so then when it comes 70 or 80% of the initial capacity means then what happened, that is the end of the life, end of the life for the end of the life for the battery. So that type of battery is not suitable for electric vehicle. That type of battery is not suitable for electric vehicle. It will go for usaging of some other ways. Some other ways means for UPS or other some purposes we can use that battery, but it is not suitable for EV. When you come to typical battery life and charging, the battery life is depends upon the rate of charging. I told you already. So the battery life is depends upon the rate of charging. So battery life is best when you are charged slowly. Battery life is best when you are charged slowly. Slowly means minimum it has to take 4 to 6 hours to charge the battery at 25 degrees centigrade. If you charge the battery between 4 to 6 hours at 25 degrees centigrade means that is called slow charging. It will increase the life of the battery. Battery life is best. When you go for fast charging means 1 hour or less. Definitely it will impact the battery life. So here I given some typical battery life for 500 to 2000 charge or discharge cycle means then this will be called as what, slow charge. So battery with 500 to 200 cycle cost is low. Okay, cost is low. Battery with 1500 to 200 cycle means quite common and medium cost, because once if the number of cycle increases, the cost of the batteries increases, that you can identify. So from the data, see the data what I given. Battery with 500 to 1000 cycle cost is low. Battery with 1500 to 2000 cycle, it is quite common and is medium cost. Then when you go with 3000 to 4000 cycle, cost is more. Okay. So what I'm going to say means, if you want to increase the number of cycles, the cost of the battery will be increases. Okay. Then how many cycles does one need? So depends upon how much distance vehicle will drive in a lifetime. That is very important. So what is the size of the battery? For example, if you are using a 600 kilometer range car battery, 600 kilometer range car battery, the 800 to 1000 cycle gives around 5 lakhs kilometer in a total life. After that, you have to change the battery. Occasionally, we can go with fast charging. Okay, not regularly. Occasionally, we can go with fast charging. Suppose a battery having 100 kilometer range car battery, one need at least 2000 cycles to get 2 lakhs kilometer in the life. Similarly, if you take 50 kilometer range scooter battery, again it is required 1500 cycles minimum to get 75,000 kilometer in life. So 600 kilometer range car battery can fast charge 45 minutes in the full charge, about 150 kilometers in the 10 minutes. So you can able to charge the battery, quarter battery it will be charged. 150 means quarter battery you are going to charge. So the battery is very expensive. The battery is very expensive, that you have to think of. Then when you come to battery swapping, this we are already discussed about this battery swapping and charging strategy of for the best battery life. So what is the charging strategy we are going to follow? Best charge means slow at homes in night. Normally during the night times we can charge the battery in our home. We can go with slow charging. So 2 to 3 hours slow charging. At office also we can do it, because while parking the vehicle, so morning 9 o'clock, if you are parking means evening you are going to take. At the time you can go with the charging also in the office or parking. So there also it is possible to go with slow charging. And occasional fast charging. Suppose suddenly you are fixed long distance trips or vacations. While going with vacations, you are parking the vehicle in the restaurants or hotels. There you can go with charging also, or fast charging also. If it may be required, you can use it. And you can charge the charges at public places also. So, for example, uh, in the petrol pumps or office or street parking or parking lots, shopping or food complex parking also, we can go with charging the battery. And now I am going to see about the lithium ion batteries. So lithium ion batteries plays a major role in the electric vehicle. In the design of lithium ion battery, while go with the battery pack design, there will be a thermal design for Indian temperature, because based upon our country temperatures and driving conditions, we have to design the battery. That is comes under the thermal design. And also low cost cooling mechanism. Low cost cooling mechanism to withstand the 45 degrees C ambient temperature. Then another design is in the battery pack is mechanical design. So this mechanical design to ensure cells do not bulge on Indian roads. This mechanical design to ensure cells do not bulge on Indian roads. The next important system in the battery is BMS, battery management system. Okay, to get best out of each cell. That is the work of battery management system. So this safety is the major concern for electric vehicle. This will be handled by the battery management system. And when you come to cells manufacturing, the technology changes every 2 years. I told you already. In the 2 3 years back, the battery size will be reduced. 30 to 40% the size of the battery is reduced when compared to 3 years back. In India, what is the battery used in the 3 years back? Now the battery what we are used, the size will be reduced to 30 to 40% it will be reduced. That is based upon the technology changes. So every 2 years now, I told you already up to 2018. Now it maybe changes the size of the battery further reduces, and mainly we can focus cell to manufacturing. We have to give 35% value, cell manufacturing 25% value, and battery materials we have to give 40% value. This is the ratio we are followed for battery pack design. And battery materials is mainly we are going with imported only. Okay. Then what are the materials we are used for the batteries? So mainly we are using lithium ion batteries. We are using today use is lithium ion batteries, lithium, cobalt, manganese, nickel, and graphite. So India does not have much of these mines for any of these. So we are going to import only. So import 25 gigawatt hour per year by 2025. We are forecasting that this much we are going to import. So go with recycled used batteries. So 90% of lithium and cobalt, nickel, magnetite, and graphite being recovered. We'll go with the recycling. 90% of materials will be recovered, and need number of recycling plants with zero effluent. Still, we are required recycling plants with zero effluent. And also, India could be important. India could import used lithium-ion batteries and become an urban mining capital of the world. So, 100 kiloton battery waste available in India today. That is 20 gigawatt hour of batteries. So that wastage is also increases. That is also one of the issues that we can see later. So here in the graph, we can represent the forecasting year up to 2030. What is the requirement of material ranges. When you come to understanding the battery parameters, just I will give one example. I took one example in our laboratory, in our college. We are constructed one electric vehicle, solar battery operated electric vehicle. For this, we are considering these battery parameters, same battery parameters I had taken for example. Consider a battery of 48 volt battery, 48 volt lithium ion battery with a capacity of 15 kilowatt hour. So if you want to find out what is the battery capacity, can also be defined by its ampere hour. So we are 15 kilowatt hour is the battery capacity, we can say 15 kWh or ampere hour. So 10 Ah battery, 100 Ah battery, 50 Ah battery, like that we can define in the ampere hour also. So the capacity of the battery we can represent in the kilowatt hour or ampere hour, anyone. Okay, kilowatt hour or ampere hour. If you want to find out the battery ampere hour, so capacity divided by the voltage. Capacity is 15 kilowatt hour, voltage is 48 volt battery. Then what is the ampere hour of the battery is 300, approximately 300 ampere hour battery. So by this way we have to calculate the ampere hours. So if you know the voltage and capacity of the battery, then we can go this by this method. Suppose if you know the voltage, if you know the battery ampere hour, if you want to find out the battery capacity, means battery capacity is equal to battery voltage into battery ampere hour. So you can use any of this. Okay, using this formula, you can calculate the capacity also or battery ampere hour rating also. So normally the battery can be represented in the ampere hour or in kilowatt hour. Okay, so the capacity if you know, then it is very easy to find out the ampere hours. Okay, so the next important topic is state of charge, SOC. In the battery we can call it as SOC. SOC of the battery is measure of percentage of batteries charged. So how much percentage of battery charged, that can be expressed in SOC. For example, I will say 0% SOC, 100% SOC. If I am saying SOC as 0% means battery is discharged. SOC 0% means what is the meaning? Battery is discharged. Suppose if SOC is 100% means battery is fully charged. Is it right? So SOC is what? State of charge. State of charge of battery is a measure of percentage of battery charge. Your SOC 0% means battery is completely discharged. SOC is 100% means battery is fully charged. That is the meaning. So we are going to measure the percentage of battery charged in terms of SOC only. For example, if I am considering an output voltage of the battery pack varies with its SOC, for 48 volt lithium ion battery, same I am considering 48 volt lithium ion battery, the voltages varies from 43 to 56 volt depending upon the state of the charge. Depending upon the state of the charge. When the battery voltages comes around near to 43 volt, 43 volt means what is the SOC at the time means SOC is 0%. When the voltage comes to 43 means what is the meaning? The battery is discharged. Battery is completely discharged. That is the meaning. Even though if voltage is 43, the battery will be considered as your SOC as 0. SOC 0 means discharged battery. When the battery voltage is around 56 volt, when the battery voltage is around 56 volt means when that time what is the SOC means SOC is 100%. When the SOC is 100% means battery is 56 volt. When the SOC is 0% means battery is 43 volt. So for a 48 volt lithium ion battery, while fully charged means it will reach up to 56 volt. Okay, a 48 volt lithium ion battery when it charged fully at the time what is the voltage mean? The voltage is maximum at 56 volt. 56 volt means your SOC is 100%. Suppose you have started the use of the battery and voltage reduces when it comes to 43 volt means now we can say the battery is completely discharged. At the time what is the SOC means? SOC is 0. So I think you can understand about the SOC. Now, going for charging and discharging at C rate of battery. C rate of battery. Same 15 kilowatt battery you can take into consideration. I am going with charging the battery with C rate, 1 C rate, 2 C rate, 4 C rate, point 1 C rate, like that different C rating will be there. So let us see what is that. For example, 1 C charging and discharging means what? 1 C charging and discharging means what? You are going to charge the battery or drain the battery fully. Okay. Do the process of 1C. The process of 1C, 1C rating, charging or discharging. That means discharge means SOC comes 0%, charged means SOC comes 100%. So you are varying the SOC from 0 to 100%. Okay. Within 1 hour means that is called 1C charging, discharging. Within 1 hour, if you are doing means you are charging, you have one 15 kilowatt battery, you are charging the battery within one hour. That is called 1C rating charging. 1C rating charging. Suppose if you go with 2C rating charging, 2C rating charging. So you are going to charge or discharge the battery within 30 minutes. Within 30 minutes. That is called 2C rating. So compared to 1C, 2C is fast charging. Okay, compared to 1C, 2C is fast charging because within 30 minutes we are charging or discharging will be completed. Then 1C rating, 1 hour it will takes. If I go with 4C rating, if I go with 4C rating, see that if I go with 4C rating, 60 watt-hour charge or discharge rate fully in 15 minutes. 16 kilowatt you can charge or discharge rate fully in 15 minutes. That is called a 4C rating. Then 0.1C rating is also there. 0.1C rating you will get 1.5 kilowatt or charge or discharge in 10 hours. Next, we'll go with the defining of EV battery life. We are considering battery with capacity of C. We are considering the battery with the capacity of C to start with. Over time, the capacity decreases due to aging or time, charging or discharging cycles. So the overtime of the capacity decreases. I told you already. For example, see that in calendar life, 1%, 2% of the capacity losses per year. For example, 100 kilowatt hour battery will be there means after 1 year, the capacity is 90 kilowatt hour battery only. Due to aging or calendar life, the battery capacity will be reduces. 100 kilowatt hour battery after 1 year, 1 to 2%. That means around 90%. The battery capacity is 90% only at the time. So that is not a 100 kilowatt battery. After 1 year, that is a 98 kilowatt hour battery only. Similarly, charging discharging cycles also, the batteries, how you are charged, how you are discharged, that also decrease the battery capacity. Okay. So I told you already, occasionally we can go with the fast charging. Regularly we are doing with the fast charging, definitely these charging cycles. What they are mentioned, 1,000 cycles. For example, if you are buying the battery, they are mentioned as 1,000 cycles means you can able to do 1,000 times charging and discharging. Okay. But if you go with the fast discharging means definitely what they are rated, what they are quoted cycles, you will not get. Definitely the battery capacity will be decreases if you go with higher charging and discharging. Then battery life. When you see the battery life, I told you already, uh, because of this aging, charging and discharging, the battery life will be decreases. So if you are considering a 100 kilowatt hour battery, because of aging, because of charging and discharging, the capacity will be reduced to 80%. 80% means what is the meaning? Due to aging, due to charging and discharging cycle, 100 kilowatt battery, the capacity reduces to 80 kilowatt hour battery. At the time, when it comes to 80 kilowatt or less means, then it will be considered as end of the life for the battery. This type of battery is not suitable for electric vehicle. This type of battery is not suitable for electric vehicle. For example, here I given see there one example. On 15 kilowatt battery is there. End of the life or life of the end of life capacity is 12 kilowatt hour. That is 80%. 70% means 10.5 kilowatt hour. When the battery life reduces to 12 kilowatt hour or 10.5 kilowatt hour means that battery is not suitable for electric vehicle. Okay, that battery is use of second life of the battery. Second life of the battery means any other additional purpose, for example UPS, some other purposes we can use it as a storage device, not for electric vehicle. So be clear, when the battery capacity goes less than 80% means that is not suitable for electric vehicle. Then while revisiting the battery energy capacity, battery will be designed for certain energy. So how we can calculate the whatever rating that we have discussed. Then important thing we have to come for depth of discharge, DOD. So depth of discharge. For longer life, never fully emptied or fully charged the battery. See, even our mobile also, regularly we are using mobile. Most of the time what we are doing means we are using the battery less than 20%. Actually, we should not use like that. So if battery showing always you have to use your mobile phone also. Our mobile phone also we have to use about 20% of battery only we can use it. When it comes less than 20%, immediately we have to go for charging the battery. So if you go with the empty discharging means the depth of the discharge is completely dried. So what will happen? The lifetime and capacity of the battery also decreases, and life cycle of the batteries also reduces. So the depth of the discharge is very important. Always we have to use 85% of the total capacity. So always we have to use 85% of the total capacity. By this way, we can calculate the depth of the discharge. So how much is the usable capacity means, for example, if battery capacity reduces with each discharge and charge cycle, we know already. When the battery capacity is remaining or SOH is Y percentage, typically 80% of initial capacity, the range get proportionally reduced. So the battery life for the EV is over and needs for replacement. So what is the end of the cycle life means? Usable capacity is X, Y into C. C is the charge rating. So what happened? 0.8 is the X rating, that is depth of the discharge. Then Y is what? The battery capacity remaining. So around 85% or 80% is remaining. So 85 means 0.8 into 0.85 into C, which is equal to 0.68 C. When it comes to 0.68 C, there is no use of that battery. So second life of EV battery, what we can do means once the battery reaches to 70 to 80% of the initial capacity, they can be used in fixed storage applications. Fixed storage application means, for example, like UPS and inverters or grid storage, we can go use of these batteries. Once 70 to 80% the capacity is reduces, then no need to go with EVs. Okay, so replacement of batteries essential for the particular batteries. And batteries can be used about 50% of capacity. Number of cycles may be from 80 to 50%, maybe much as 100 to 80%. That is based upon the secondary life usage. Then when you come to battery pack, is made using battery cells. The life of the battery pack is primarily depend upon the life cycle of the battery cells. So the cycle life of the battery cell is a fundamental parameter, depends upon the chemistry and also many other factors such as C rating, charging and discharging, temperature, charging and discharging, and also we have to see the storage temperature and depth of the discharge. So a percentage of SOC is left at the top and bottom. So you should not go completely depth of the discharge. And temperature usually we have to maintain at 25 degrees centigrade. What is the C rating we can follow is 0.1 C. What is the battery SOC we have to maintain 10% and 80% we have to maintain. That means you should not bring to 0%. You should not bring to SOC is 0%. That is the meaning. So DOD is percentage of SOC. We have to maintain left, top and bottom in charging and discharging. We have to maintain minimum 10%. 10% means what? Uh, uh, for example, that 48-volt battery, SOC 0% means that is 43 volt. So more than that, we have to maintain. We should not go further reduction of that. Okay. Then the factors affecting the battery life cycles, that is the rate of charging and discharging. So here, a lithium-ion cell manufacturer guarantees thousand cycles under the conditions like if you are charging C by 2 rating, charged at C rate at 25 degrees C with 85% DOD, then you will get 100% cycle. So what is the manufacturer will given the specifications or care to taken care of charging and discharging. If you are followed, then only you will get the manufactured set life cycles. So if they are giving 1000 life cycles means if you have followed the guidelines of charging and discharging rating, then only you will get the 1000 life cycles. Suppose if you are not followed, the life cycle will be decreases. That is the meaning. So here two graphs are there. You can see the graphs. If I am go with increasing of C rate, what happens? The number of cycles will be decreases. In the second graph, you can see go with higher charge ratings. So you can see the number of cycles also decreases. So 2 ampere means it will be more. 20 amperes means it will be less. That you can identify easily. Then temperature. So I told you already, the temperature is very important. The battery life is depends upon the temperature also. So higher temperature means you should not go 40 degrees C or more. Okay. So lower temperature is equally problematic. Similarly, lower temperature also equally problematic. So you have to maintain the minimum temperature range to maintain the maximum lifeline. So here in the graph you can see 1C rating, 2C rating, 3C rating, different charge rating graphs are represented. This graph will be drawn between the cycle life and then temperature. So we have to maintain the temperature range within the maximum cycle life. Then only the life of the battery will be increases. That we can prove from these characteristics. The next one is storage cell cycle life is also impacted by depth of the discharge. So what is the percentage of battery is used? That is called depth of the discharge. So I told you already. So if you are using mobile phone, we are not going to usage of less than 20% of battery. Okay. So if you go with lesser than that means what happens? The life cycle is decreases and the capacity of the battery is decreases. In the same way, for electric vehicle also, what type of battery, not type of battery, how your DOD is maintaining. That is very important. So I told you already, top SOCs you have to maintain from 0 to 85%. Bottom SOC of the window we have to maintain 15 to 100%. The middle window you have to maintain 5% to 90% of DOD. So 80% of DOD is maximum we have to maintain. And also if you see the DOD increases, the number of cycle will be decreases. So when you come to sum up the battery capacity, battery cost, and then battery life, these three are all related to each other. We have discussed already. So all these things is depends upon the rate of charging or discharging, temperature, DOD, and other key parameters like SOC, EOL, C rate, cycle life, and aging calendar life we have discussed. And see from the characteristics if the number of cycles and the discharging capacity for the different C ratings, 1C, 2C, and 3C, how it will be changes that we can see from these characteristics. The next one is chemical battery. Chemical battery history, we are using normally two types of batteries, that and all we know very well. So rechargeable batteries will be used for electric vehicle. So these rechargeable batteries, mainly we go with a lithium ion battery. The battery selected to match the vehicle requirement, that is very important. So what are the Parameters we can choose while selecting the battery for EV. First one is cost per kilowatt hour, specific energy density, volume energy density, life cycle at certain C rate and temperature at certain DOD, capacity and DOD usable, C rate usable, safety and safe disposal. So all these parameters we have to choose before going to select the battery for EV. And why we are using lithium ion battery. So all these things will covered by the lithium ion battery. I will tell later. Okay. See. So why I am chosen lithium ion battery. So this data I took from batteryuniversity.com. So from their surveys, they are compared the batteries, lead acid batteries, nickel, cadmium, nickel methyl hydride battery, and lithium ion batteries. Here you can able to see when compared to all other batteries, if you go with lithium ion based cobalt or lithium ion based manganese or lithium ion phosphate batteries, you can able to see the life cycles. Life cycle is 1000 to 2000 you will get. So why we are giving preference for lithium ion is obviously the life cycle will be more. So that's why we are giving preference for lithium ion battery. And these are the 8 acts of a battery: high specific energy, high specific power, affordable price, long life, safety, wide operating range, toxicity, fast. So all it covers by the lithium ion battery. So we are going with lithium ion battery for electric vehicle. And also these are the battery packs. Battery pack need 3 designs, mainly electrical, thermal designs, and life, durability, performance, safety. These are the very important factors we have to see while seeing the battery pack. The design process, electrical design, mechanical design, thermal management, and battery management system. The safety aspect concern, the BMS system plays major role. This is the importance of electrical designs: capacity, voltage, current, high voltage isolation, short circuit scenarios, efficiency, power delivery. Then thermal design, improve pack efficiency, mitigate thermal accident, increase cell or pack life. Then importance of mechanical design is safe structure for extreme conditions, cost, productivity, reliability, and ease of assembly and service, aesthetics, compactness, and lightweight. Similarly, in the way of BMS design, maintain cell pack operation limits, prevent safety concerning events, control thermal system, communication, and diagnostics. Everything will be covered in the BMS design. So this is the stages of battery pack design. Various stages will be the cell configuration, structure, safety, control, and applications. This is the major components of battery pack. So we know already about this battery pack. These are the major components we are used in the battery, lithium ion battery pack. So battery is the major issues, challenges we are facing in the electric vehicle. Now we can move on to driving change on the grid. The impact of EV adoptions, there will be utilities and other power generators need to prepare. Now for increased loads as the electrification of transportation grows. With any challenge and opportunity exists for these willing to invest in the electric vehicle infrastructure and customer engagement. So what happened? The day by day, the increase of electrical vehicle, the growth of demand of electricity. So the utilities, what we will use EVs to manage the demand, and also we can integrate the renewable energy sources and maintain the stability of the grid. So this is the electricity demand by EVs in the 2030. So from this analysis, we can able to see the how the demand will be there in the future in the 2030. So just I given one model of the parking garage use case. So with grid connected parking garage for charging the charging stations. So grid will be connected with variable renewable energy sources like solar. Here I have shown only the solar panel, and many sources are connected with the grid, and multiple vehicles are charging at a time in the parking garage. So there will be a input. We require data for real PV generation and data for commercial EV fleet and data for long-term EV customers and data for short-term EV customers. This is one model of parking garage I shown for reference. Then when you coming to electric vehicle cost, so see the cost comparison. In the blue and green color, it indicates blue means IC engine vehicles, green means electric vehicle. So for the interior design, around 9% is 9% of the cost is required for electric vehicle, means for internal combustion engine it is 24%. For body, exterior body also, the dominating cost is IC engine cost. 25% is required. For controlling electronics also, 18% is higher for internal combustion engines. For chassis design, when you come to chassis design also, 15% cost will be high. See, interior design, exterior design, controlling electronics, chassis. In all the designs, the overall cost of the internal combustion engine is high when compared to electric vehicle. So, cost required for these works, interior work, exterior work, and controlling and chassis work, cost required is very less. But in case of powertrain, coming to the powertrain, in the powertrain, see the cost, how much it will be there. For internal combustion engine powertrain, 18%. For electric powertrain, 51% is required. The cost, because of this electric powertrain cost will be more here. So mainly that battery cost. Okay, maximum dominating cost is even motor controller cost is also in the affordable price. It is very lesser cost only, but the battery cost will be very high. So see that for all the works, internal combustion cost is more. Only for powertrain, electric cost is more. Okay, so this is also one of the challenges why people are not ready to moving towards the electric vehicle. But running cost is very less. Operational expenditure cost is very less, but capital cost is more for electric vehicle. But running cost is very less. But in the battery aspect, once a certain period of lifetime, we have to go for replacing battery. At the time, again, you have to spare a good huge amount for battery replacement of the battery. This is the issues, still challenges in the electric vehicle. Just I am comparing the electric vehicle cost available in the market. Mahindra E2O plus one car will be there. Just I am comparing with the low range cars with one petrol cars and then one electric cars. See the mileage. See the mileage. We are expecting from the Mahindra E2 not plus. We are getting 120 kilometer, means petrol cars we can expect up to 620 kilometer. To charge one time it will takes around 12 units, means to charge the petrol car we can fill the liters up to 40 liters. Then energy usage per day is 0.10 unit, means here 3.125 liters per day. What is the cost you are getting? 7.3 per unit for 400 to 800 units. Suppose that is electricity charges will be changes depends upon the slab rating based upon the uh, consumer utilization. Different slab ratings will be there. Tariff will be fixed based upon that. So approximately if 400 to 800 units means around as per Tamil Nadu Electricity Board concern, you will get around 7.3 per unit cost. The petrol cost is, this is old data, now it is not 82.25 liters. Now the cost will be more. Now around more than 100, the petrol cost will be high now. So even the cost of the electricity is same now. This petrol cost is now recent 6 months before I took the data. This now the rate is more than 100 rupees. Now the cost will be more for the petrol we are spending, and the cost per kilometer 0.73 paisa. Now here rupees 5.140 per kilometer we are spending. And one day expenditure, suppose you are daily traveling 50 kilometer average travel, means per day how much for electric vehicle you are utilizing 36.5, but here for a petrol car, you have to go with 257 rupees. So how it will be differ, you can see. This is the operation cost. Operating cost is very, very less for electric vehicle. And monthly expenditure for traveling, monthly expenditure, if you are calculated for 25 days travel, around 1,000 rupees it will come for the electric vehicle. But if you go with the petrol car, around 6,500 rupees around. So how much difference will be there for the operational cost if we can think of that. Next, this is the various uh, electric cars available in the market as of now. The lowest price is Tata Tiger EV model one. It will be the price starts from 10.58 to 10.90 lakhs. The highest is Audi e-tron will be there. That is comes around 1.17 crores also. So many vehicles are available in the Indian market. So we are seeing the road, we are seeing the market, we are seeing now advertisements also. We are most of the people we have started to use of electric vehicle. Even though if you have challenges, issues will be there. Be one by one challenges, issues will be overcome in the future. Okay. So as per the operational expenditure cost, based upon the current scenario, current petrol and diesel cost, you can go with electric vehicle surely. This will be overall calculation. If you put initial capital cost will be higher, but anyway the running cost will be very less. So it may be good. My suggestions. And when you're coming to the charging station finance and ownership, because uh, everybody thinking of that only, because even though if you're ready to buy the electric vehicle, where we can charge. Okay. So when you come to our home, vehicle is in our home, that time you can charge the vehicle, no issues. When you are going outside, then where you can charge. That is the main thing. Customers are thinking in that way only, because wherever we go, we can able to identify the petrol stations easily. But charging stations for electrical vehicle still not up to the mark. So it may become in the future, because the government of India has taken many decisions to uh, install more number of charging stations in India between each 3 kilometers in cities. 3 kilometers once one charging station they are planned to adopt. In cities all in highways 25-kilometer distance they are planned for charging stations. And based upon these charging station finance and ownership, this is the one type of investment nowadays we can say as this is the one type of investment we can go with invest in the charging station. You will be become a ownership. You will get a owner. You are maintaining one charging station. You will get profit also. I have one calculation. I will show it how you can earn profit from the charging station. Um, Now, the government of India has made an ambitious commitment to the creation of demand for EVs through a faster adoption and manufacturing of electrical. That is called FAME. So, government has introduced one FAME India scheme. From this, what they can do means faster adoption and manufacture of electric vehicles. Because mainly for why we are going for government is promoting mainly for green energy. So electric vehicle and non-availability of petrols. So because we are depending on others to get petrol from other countries. So the cost of the import and expenses and the transmission. So most of the costs will be included. That's why now the cost will be increased at that much level. So we are going to promote the electric vehicle. Niti Aayog is one of the concern. They are also giving advice to center and states for the development of charging station. So in the charging stations, India has made a strong commitment to electric mobility. The country has EV transmission gaining traction due to demand creation, state EV policy, and domestic manufacturing. So simultaneously, the market of electric mobility in India is growing, enabled by the policy, compelling and improving economics, and the emergency of new models and investment opportunities. This is the first one is a demand creation. So demand creation under the FAME India scheme, FAME 1 and FAME 2, they are going to support the customers, by giving some incentives for buying the vehicle, to promote the electric vehicle among the customer sites, they are started to use. And also for the provision of stations also, the government will support in all the cases to get a entrepreneur. So anyone can be entrepreneur by uh, creating a own charging station and be a owner in the future. And many states in India, around 16 states, they have started to use of EV policies. Even 10 states are there completed. They are having own EV policies for the forecasting of up to 2030. How many charging stations to install? How many vehicles has to be in the market? Everything they are having some policies. That policies they are created, they are following. More than 10 states, they are already created the policies. They are started to implement the policies. Some other 6 states in the draft version, they are also created the policy. It is in the draft version. They are going to implement shortly. If some few states are pending in the creating and promoting the EV policies till now. When you come to domestic manufacturing, the India EV startups have raised around 4,490 crore between 2014 to 2019. So to increase or highlighting the potential of EV business models. Business model in the form of ride share, delivers, commuter service, or last mile connectivity. Anyway, let them start to create a startup, and then let them have create their own business models. So I will give one example. Suppose if you want to start one charging station, own charging station, how much cost it will take in India means in India it may be varied from 1 lakh to 40 lakh. That is depends upon the type of charges. What type of, because charger cost is plays major role here. Okay, charger cost is plays major role. So that depends upon the what type of charges you are chosen. We can able to the cost EV charging station cost EV charging EV charging cost maybe changes charging station cost maybe changes from 1 lakh to 40 lakhs. So this is the step by step guide for set up EV charging station in India. So first we have to understanding the worthiness of investing in the EV charging station. First you have to understand, because today you may not get that much of profit. In future you will get a good profit based upon the EV charging station. We can assure based upon the calculation we can come to conclusion. Finally we have one calculation also. Then government initiatives. So what are the government initiatives taken for this, and also what is the cost for set up this charging station? Charger cost, electricity and software cost, infrastructure cost, manpower and maintenance cost, and advertising cost. So these are very important for setup. And also infrastructure setup requirements. Infrastructure setup requirements and business revenue model. So this is very important. So these are the step-by-step guidance we have to follow for setting a EV charging station. So is it worth investing in the setting up a EV charging station in India? Definitely. So as per the infrastructure guidelines set by the government, it is compulsory to set an EV charging station at every 3 kilometers in the cities and 25 kilometers in the highways on both the sides. So for long range and heavy duty vehicles, there should be charging station at every 100 kilometers on both the sides of the road, mostly in highways. And also India working on the developing Delhi to Mumbai electricity highway to boost industrial transport. Already India working on this. So under the implementation of FAME scheme phase 2, the government of India is planning to install around 1,000 plus electric vehicle charging stations before 2023, and also already asked for bids from companies. What is the cost of setting up an electric charging station in India? I told you already it will come around 1 lakh to 40 lakhs. That is depends upon the type of the charger what we are using. So here charger types, various types will be there, and cost is also listed. You can able to see different type of charger and cost of the charger also. CCS charger having the cost approximately 12 lakhs 50,000. And other cost for setting up an electric charging station in India, you have to get new electricity connection, 250 kVA transformer, separate transformer we have to install in your place. That cost will come around 7 lakhs 50,000. New electrical connection we have to buy from electricity board with 250 kVA substation. And then civil works around it will take 2 lakhs 50,000. And EVSC management software plus integration, it will take around 40,000. Technicians, manpower, maintenance cost, etc. It will come 3 lakhs 50,000 yearly. And advertising and promotion is also there for 50,000. It will be there. And land lease. Suppose if you don't have own land, we have to go with land lease. Approximately, it will take 60 lakhs. 50,000 per month means approximately it will take 6 lakhs per yearly. So the total approximate cost around it comes 40,000 first year, including setup if the land is at lease. So annual maintenance cost, approximately we can keep the annual maintenance cost from the second year onwards, 10 lakhs it will come. That is including land lease. 6 lakhs for land lease, 4,000 for maintenance cost. So what are the minimum infrastructure requirement for EV charging station means? A transformer with subsequent substation. That is called, I told you already, 250 kVA transformer is required along with the safety requirement. And also for the purpose of metering termination, there should be a 33 by 11 kV cable with related equipment. Appropriate civil work should be there. There should be adequate space for charging and entry or exit of vehicles. Then necessary local certification also required based upon the state norms. When you come to the business model, analyzing the business model, suppose you are investing 40 lakhs for the charging station. Just we can check how much revenue you will get. For example, we get approximately 500 to 800 kilowatt hour per day. 500 to 800 kilowatt per hour day EV power consumption means, then you can calculate what is the electricity utilization for 360 days and fixed margin of rupees 10 per consumption. So we can consider rupees 10 per consumption means, for example, in the first year, 200 kilowatt per day if you are using for first year means 200 into 360 days into 10 per consumption. So you will get 7 lakhs 20,000. For 300 kilowatt hour per day for second year, you will get 300 into 360 into 10 means you will get 10 lakhs 80,000. Similarly, you can go for 500, 750 and 800 kilowatt hour per day for fifth year. So what is the total revenue for 5 years? So 1 to 5 years you will get around 91 lakhs 80,000. Then software management, other managements, it will goes around a margin of 4 lakhs 59,000 means what is the revenue you will get 5 years? 87 lakhs 21,000. It's a good idea, good business. Anyone can do it. Okay, but you immediate revenue you cannot get. But after 5 years, it may be a good revenue for everyone. And when come to conclusion, there will be 1% of EV in India as compared to traditional vehicles. Compared to traditional vehicles is 1%, but increasing compared to traditional number of traditional vehicles as of now 1% only. The sale of EVs are going upwards and requirement of charging stations also rising daily. So if you have an investment capacity and you are willing to become an entrepreneur with a broader vision, now it is a good time to investment. So in to invest in EV charging stations. So the challenges and opportunities, challenges is also there and opportunities also there. So challenges are day by day it is reducing. So my advice is the growth of EV is not there. No one will going to stop. So definitely the challenges anyway, one by one the challenges may be going to reduce. The percentage of challenges definitely it may be reduced. And earning from this, we are getting the opportunities like this. creating a charging station and become a ownership or entrepreneur, it may be possible in the future. Okay. So this is one solar battery operated electric vehicle. This is our we are constructed one electric vehicle. It is operating. It is well running in our campus. These are the references. Thank you. If you have any queries, please.
Thank you, sir.
Thank you, ma'am.
Dear participants, do you have any queries?
Sir, good afternoon, sir.
Yeah, very good afternoon, sir.
Sir, I have a small doubt. Regarding the heavy vehicle transport, the goods transport vehicle, how it is possible, sir, like lorries and trucks?
Yes, sir. Now buses are there, sir. Sir, in Tamil Nadu, recently so many buses they are operated through electric only. So heavy vehicle also it will come, sir. But battery cost will be there, sir. That issue will be there. But we can do it. But the vehicle weight will be increases. For heavy vehicle, already the load is more. But we can do it. But it will take some time. But now also it will be there, but not up to that level.
So yes, sir. If you could able to improve that the battery size,
definitely, sir. Most of the researchers are, most of the research mainly that's why I'm taking battery, sir, because challenges means only battery is the challenges for us.
Yes,
so
sir.
that's why mostly I concentrated on the battery only. So definitely, because I told you, sir, already compared to 3 years back, 30 to 40% of battery sizes will be reduced. So then weight will be reduced, then efficiency will be improved. Same may be happen in the future also. So many researches going on there. Maybe it will come, sir, surely.
Okay, sir. So nice
Thank you,
session, sir. It is excellent presentation. All you have covered. It is a boosting to the entrepreneurs to become entrepreneurs and startups.
Yes,
All
sir,
the
this is
aspects you
good.
covered.
Yeah,
Okay,
yeah.
thank you, sir.
Thank you very much, sir. Thank you, sir.
Any other clarification, sir? Okay. Sir, thank you. Thank you for your detailed and well informative session. Thank you so much, Ramesh, sir.
Thank you, madam. Thank you, madam.
Sir, shall we wind up the session, sir?
Yes, madam.
Thank you, sir.
Thank you very much.
Just a minute, madam. Madam, organizers.
Yes, sir. Yes, sir.
So thank you, madam. I am from mechanical engineering. I am professor and head of University of Technology. We have the vehicles design sector in the automotives, madam. Go karting and quad bike, formula vehicles our students are doing. And we have started the e-vehicles this year, madam. That's the reason I have registered. So when I see the ATAL portal, it is the e-vehicle is there. So immediately I have registered, and thank you for organizing such a wonderful FDP, madam. It is information which is required to be shared to even among the students also. And I think I congratulate Madam Shyamala, madam. You have taken the risk and all the ways, everything you have well organized. Thank you, madam,
Thank you,
for
sir.
organizing such a wonderful program.
Okay, Dr. Ramesh sir, Mr. sir speaking.
Yes, sir. Yes, sir.
Very nice session you have delivered.
Thank you very much, sir.
Important
Your blessing is always required for me, sir.
And
For a senior
thank you.
professor, getting from this kind of words from you, I am very happy, sir. Thank you so much, sir.
And many congratulations, Dr. Shyamala Gauri, madam. She has organized and in very well manner. Thank you very much.
Thank you, sir. Thank you.
Okay.
Yeah, once again, thank you, madam, Shyamala, madam. Thank you for everyone and other coordinators also. Thank you.
Thank you, sir.
Thank you.
Thank you so much, sir.
Okay, thank you.
I again thank all the participants for your all patient listening and kind cooperation. Thank you all.
Shall I leave, madam?
Yes, yes, sir.
Madam, now the test start, madam, now?
Yes, sir. You can start the test and the assessment link I have sent in the group, sir.
Yes,
and
madam.
attendance also given in the group, sir. You can start the test, sir.
Okay, madam. Thank you.
When we have to submit the test, madam?
Sir, within 2 days, sir.
And within 2 days till up to?
Sir, within today, up to 12, tomorrow only I am going to enter the test marks in the ATAL portal, sir.
Okay. Because today is the last date of submission of proposal at SERB, CRB. And
Okay.
we are submitting a proposal in collaboration with IIT Roorkee. That's why I want some time.
Okay, sir.